Hiya! So in this video, we're going to look at an example for the symmetry and the summation kind of thing to kind of see when this helps us or how this kind of helps us. Because right now it's probably like, this is so much confusing around like where the fudge are we actually going to use this? Like where does this work? So let's look at something here. So we have 101 independent random numbers from the set 0 through 9, right? So I have 0, 1 through 3, all the way up to 9, and I just took 101 sampling with replacement, right? Think of it this way. If you want, you can think of these as grades on some 9-point assignment. So you can have you got 0 marks, you got 9 marks, or you're like your GPA, right? A 9 is a perfect, 0 is a really, really bad GPA. So you can think of this as you got 101 grades in class, or you're looking at 101 students in a class, and you're looking at their grades, yeah? And so now that I'm going to ask, find the probability that the sum of the numbers is less than 455. So I want to add up all of the grades, and I want to know when is the sum less than 455. So let's kind of look at this. So let's make xi be the random variable. So it represents, so is the ith random number. Okay. So in other words, it's the ith draw. And notice how in this case, if I look at p of xi, this is going to be symmetric. If I look at xi, this is symmetric about 4.5. Now let's think about this a minute. Why is it equal to 4.5? Well, if I look at the probability of 4.5 plus 0.5, what is this? This is the probability of 5. All of these are random variables, so I'm randomly choosing. And so this is going to be equal to p of 4, which is equal to p of 4, which is 4.5 minus 0.5, right? So we have this minus sign, plus sign and minus sign, so we're happy. Let's try it with another set of numbers. So let's try 4.5 and 4.5. So here we have p of 9. This is obviously equal to p of 0. And so we get p of 4.5 minus p of 4.5, right? And here again we have plus and we have minus, and we're happy. So this, you obviously have to do this with all the numbers, but you can kind of see how this works. Well, what happens if, well, you're probably like, well, all the probabilities are the same. Why can't we do like 5.5, for example? Well, let's try 5.5. And kind of see what happens for that. So if I have the probability of 5.5, okay, so I can add 0.5 as before. Here we have probability of 6. Well, this is equal to the probability of 5, which is probability of 5.5 minus 0.5, right? So this is okay. 0 plus and minus, and we're happy. Right, so here 5.5 minus 0.5 is 5. Okay, but this needs to work with everything. So let's try 9. Or let's try 0, right? So if I try 0, what's 0? So if I want 5.5 minus 5.5, that'll give me 0. And then what's 5.5 plus 5.5? This is 11, right? Probability of 11. Well, probability of 0, this is 1/10, right? Because we know that, well, we're assuming it's 1/10. And so we have some number here, but we will never ever get 11, right? So this is 0. So we can't have this. So that's why this is symmetric about 4.5, because 4.5 is the only number where if I do plus or minus, I get the same probability. So that's why it's kind of 4.5. Sometimes you have to mess around, but usually the way to kind of find this is it's going to be the average number. So if I were to take all the numbers and add them together, if I'm not screwing that up, it should be that. That's kind of like the middle point. Okay, so we know why 4.5, why it's symmetric about 4.5. How does that help? So if I want the sum of the numbers, well, here I would need to add my numbers. So s is equal to x1 plus x2 all the way up to x101, right? And we're asking when is the probability that s is less than 455. So it's going to be less than or equal to 454. Um, okay, so remember now we can do our little symmetry game, right? So let's kind of play our game. Um, so what is S symmetric about? If we look at beforehand, um, if we have xi are symmetric about vi, then Sn is symmetric about the sum of the vi's. So I need to sum up all of the vi's. So the sum of the vi, well, I have, this is just the sum of 4.5 from I equal 1 to 101. So if you think about this, is just 101 times 4.5. And if I do this, I get 454.5. So we're going to take this probability and we're going to use, let's go back, we're going to use this formula here to kind of, we know it's symmetric about 454.5, so let's use this formula to kind of give us the number, like to kind of see what happens. So here, let's convert this to 454.5. So this is equal to S less than or equal to 454.5. So I have to add 0.5, so I have to subtract 0.5. This, we're told, this must be equal to the probability that S is greater than or equal to 454.5 plus 0.5, right? That's literally what we're saying up here. Let me go back. We have the less than or equal to, and we have the greater than or equal to. Less than or equal to is with the minus, greater than or equal to is with the plus. So we have less than or equal to with the minus, greater than or equal to with the plus. And then we can add these up, and we get S is greater than or equal to 454.5. Sorry. Well, that's, if you look at this, this is all the numbers in existence. That's basically everything. And since 454.5 is the middle, that means the two are, like, these two things are the same. So if I do P of S less than or equal to 454 plus S greater than 454.55, well, this is the this is equal to 1, right? This has to give me full probability because I have to get everything. And so if this is equal to this, I can just put them together. 454 plus S is less than or equal to 454 is equal to 1. So this, we're using this kind of chain here, right? That's how we did that part. I guess I shouldn't do that part. And then here you can kind of see I have two of the same thing, so I can just add them together. That's not a big problem. And so I get P of S less than or equal to 454 is equal to 1/2. And that is our final response. So it's kind of weird in this regards in that, oh, like it's just a half and it seems super easy, but it's also a little complicated because you have to see that it's symmetric. And it is a little bit hard to see, but you can kind of see when we look at symmetric things, life does become a little easier. So if you know a function is symmetric, then you should see if that kind of helps. And that might help, that might not help, I don't know. But it might be something that could help, especially if you're doing some kind of summation thing or something in that regards. So I will end this video here, and I will see you on the next video about expected value, which will be the last section for this week. So I'll see you then. Bye.